Ooh, okay. Number 2. I have a lot of these guys here. Holy crap. Okay, let's see. I might just go and break this down into kind of problems here, but I have 2. So this is classify each substance as strong acid, strong base, weak acid, or weak base. So my first guys here, HBr, or let me, I guess I'll just write these down and then I'll go through it as well. So HBr, I have hydrobromic acid. This is a strong acid because this associates into, this guy associates fully into, if I add H2O, dissociate fully, it's not in equilibrium. I'm going to get Br minus and H3O plus. So my hydronium ion and Br minus. So therefore, this guy here is a strong acid. The same thing applies for HCl, is also a strong acid because of this reaction here. It's going to dissociate fully. I'm going to get my hydronium ion and my chloride ion, and it's also a strong acid. And exactly the same thing for HNO3, which is nitric acid. This here is also my strong acid because I know it dissociates fully. Strong acid. HCl4 is now different. So the reason why is HCl4 is different because if I write down HCl4 here, and if I do the reaction here, this here is, this here is perchloric acid. If I add water to this, this is actually not going to dissociate fully. It's going to be in equilibrium, and I'm going to form my H3O plus because it's an acid here, and I have my ClO4 minus here, which is my perchlorate ion. And this here, this is actually a weak acid because it does not dissociate fully. So that's HCl4. Let me just check my answers. Let's check my answers here. So it says here, oh, they put it in, I don't know what order they put it in, but HBr is strong acid, which is good. HCl was here a strong acid, that's good. HNO3 is also strong acid, that's good. And HClO4 should be a weak acid. HClO4, where do I see this? HClO4, I don't think they put it here. They put HCl3 minus, but I don't think they put HClO4. Weird. Okay, but this one we know it's a weak acid, so I don't think they included it in the solution here. But this is a weak acid, and I don't think they verified here, which is okay. HNO2 is different. So HNO2 here is going to be a weak acid, and the reason why is because of the second dissociation. So I have HNO2 plus H2O. This will be in equilibrium with, again, I have H3O plus, in this case, I have here's NO2 minus. And this here is a weak acid. And this is nitrous acid here is a weak acid. Nitric acid is a strong acid. Nitrous acid is going to be a weak acid here. So this guy here is a weak acid, which is good, and that's what they got here. H2CO3 is kind of my next guy here. And again, basically the concept of this here is, what I'm doing here is I'm just writing out the equilibrium reaction, right? And seeing whether or not it dissociates fully or does it not dissociate fully here. So again, I have H2CO3, I'm going to add H2O to it. It should be in an equilibrium, and I'm going to remove a hydrogen here. So I have HCO3 minus plus H3O plus here. And this here will be a weak acid. So HCO3, let's see here, what is H2CO3? Did they include that as well? I don't think they included it in this problem here. Yeah, I don't think they included the H2CO3 here. So this was missing, and the HClO4 is missing, right? So let me just write this down first. HClO4, and this is H2CO3. And then, okay, next is HCOOH and C2H5COH. Both of these guys are weak acids because they're organic acids. So the rule is basically with an organic acid, such as this here is methanoic acid. This guy here would be propanoic acid. These guys here are organic acids, so therefore they're always weak acids. So 1, 2 is a weak acid. C5H5N here would be a weak base, and the reason why that is that, and I don't think they included it here as well, and it's because it's an amine, and organic amines are usually weak bases. So maybe I'll write this down here. So I have C5H5N. I'm going to add that with H2O, and this is going to I'm going to create this would be C5, get C5H6N plus, or actually I wouldn't write the 6 here, I would write 5 and I write NH here, and this would be plus OH minus here, and this guy would represent a weak base, and I don't think they wrote that here as well, so I'm gonna C5H5N here as well. Lithium hydroxide and sodium hydroxide are obviously strong bases. Same with calcium hydroxide and potassium hydroxide. So they believe they included that here. Yeah, these are strong bases because of the hydroxide. So strong bases, not strong acids, sorry. Lithium hydroxide, sodium hydroxide, calcium hydroxide, and potassium hydroxides are all strong bases here. And finally, I have, this is methylamine, which is going to be a weak base. So I have CH3 and H2. I can add that with H2O, and I'm going to get in equilibrium, I will get CH3 and NH3 plus OH minus here, which proves that this here will be a weak base because I'm creating this hydroxide ion here. So let's see. Or they wrote here weak acid actually. Let's see, methylamine should be a base here, so I don't know why they wrote a weak acid here. That is not correct. This solution here is not correct. So let's see. CH3, NH3 here, yeah. So this here is not actually not a not a weak acid here. So solution, I'm gonna say solution here is incorrect because they're missing a lot of stuff. So solution is partially correct, missing the following terms, following compounds in answer. So HCl4, I said it was a weak acid. This guy here is a weak base. This guy here is also a weak base. And I wrote that CH3NH2 is a base, not a weak acid. And I'm going to write down the formula here. So CH3NH2 plus H2O is in equilibrium with CH3 and H3 plus OH minus. So right, therefore CH3NH2 is a weak base. Okay. So I'm going to say solution is partially correct. They're missing some answers, so I'm just going to say solution here is incorrect just so I can check this answer for them as well. All right.